debris around us, right? That moraine coating. If we look over here, there's almost none. That's not a glacier. That's because there's two unnamed glaciers that come into that side of the Matanuska Glacier further up the valley. Now where those two glaciers come in, they bring the carbon from the sides of their valleys into the glacier. That creates these lines down the center of dirt, rock, and debris called medial moraine bands. And then what's interesting is as those medial moraine bands are working their way down towards the toe with the ice, all of the rock and all of the sediment in those bands, it's actually constantly moving towards the sun. Our rocks are actually classified as walking rocks. A rock out here will walk anywhere between 4 and 20 meters a year towards the sun. Smaller sediment can move anywhere between 1 and 5 meters a year towards the sun. Now the way it does it is basically if you put a little bit of sediment on top of ice, it increases melt rate. But once you get an inch of sediment on top of ice, you now have an insulation barrier. It slows down the melt rate by almost 50% at 1 inch. Add more and it continues to slow that rate down. So if you notice this big rock has this pedestal underneath it of ice, right? That's called a boulder table. What happened there is the rock actually insulated the ice that was directly underneath. The ice around the rock melts down, leaving it on that boulder table. Now, the sun here always comes from the southern side of the valley, so it comes across like this. Basically, what that does is it heats the rock up more on the southern side. So as that table gets taller, it's angling itself towards the sun. Eventually, it gets steep enough that the rock will either slide or tumble off. Moving over to the next point, now that little pedestal will go down because it's no longer insulated and a new one will form wherever it lands. We also see all these little cone shapes everywhere out here. Tons of them, right? Those are called debris cones. That's how the smaller sediment moves. Basically, anywhere you get a thicker pile of sediment on top of the ice, you're going to end up having a cone formation. Same principle, the ice around is what's melting down. There'll always be more sediment on the side facing the sun, so on the southern side of those hills. But as they get taller, they get steeper, so eventually all the sediment slides over. This is another protection mechanism that Mother Nature has built into the glacier. Okay, you take these couple of lines of dirt, rock, and debris. By the time they've made their way down to the toe or the terminus, the area that's most prone to melting away, the glacier has literally covered 2/3 of the width of itself in an insulation blanket to protect that from happening. It's pretty cool, isn't it? Now you feel that wind? That wind is called katabatic winds. So that's caused from all of the cold air coming off of the ice hitting the warm air in the atmosphere. That's how glaciers protect themselves from rain. Rain equals flowing water on the glacier, so the glacier doesn't want rain on it, right? So, well, that disturbance actually goes several thousand feet up into the atmosphere, okay? Now, so 9 times out of 10, if storms come up the Matanuska Valley, they will actually split and go both sides of the ice down here. Now, we'll watch it. It creates this beam. We call it glacier magic. It's pretty cool to watch. Now, over here, this glacier is really protected because on the southern side, we have the tallest mountains in the got over there. We got 12 and 13,000 foot peaks back there. In order for storms to make it over the southern side, they've got to drop their weight. That equates to snow at the top in the accumulation zone where the glacier needs it. But by the time those storms make it across over to here, they've already dropped all their moisture. There's nothing left in them to rain. So about the only time we see rain out here is if an extremely powerful storm comes up the Matanuska Valley, like what happened yesterday. Or if it comes from the northeast, because that's about the only area we don't have enough protection built in that they can cleanly come through. Like for instance, last year in the lower valley, I live in Palmer, an hour away from here. From the weekend after 4th of July until it started snowing the week before Halloween, we had a total of 4 days of sunshine in the lower valley. It rained every other day. Yeah. Now up here on the glacier during that same amount of time, we had 3 days of rain. It rained twice as many days in the parking lot as it did out here. Isn't that pretty incredible? And that's what we call glacier magic. So you're ever looking for a nice sunshiny day, just find a really big glacier to get on. Most likely you're going to have a better chance of it being sunshining there than anywhere else around it.